Thank you for tuning in, everyone, for the second content session of Smart Alex Summer Series. Tonight, Noah, one of our expert tutors, is going to take us through the math SAT section, an introduction, some problems, and give his tips and strategies. So I'm going to hand it over to Noah. There'll be time for questions and all of that good stuff.
Thanks, Kayla. Hi, guys. Hope everyone had a great July 4th, and we are here to dive right into the SAT math section. I've been with Smart Alec for quite some time now, and I grew up in Florida. I went to Dartmouth in New Hampshire, and now I live in New York City, and I have tutored in all three locations on the SAT. So I have quite a few years of experience doing this, and I hope that this will be a helpful session for all of you. So let's dive right in. I'm going to do my best to not retread over the same things that Nathan and Maggie have said, but some things do bear repeating. To start, so much of what we have to do as tutors is to sort of cut through the weeds for our kids, because like everyone has said up until this point, the SAT is this test that reduces everything you are into a number, and that's supposed to be what gets you into school. And that's stressful, and a lot of kids feel stress about that. They've heard about this test, they've been worried about this test, and now they finally have to perform on it. And so even though some of these strategies might just be general test-taking strategies, it is helpful to try and to make the test seem like a game or like a puzzle. The more that you can get the student aware of sort of what's going into the process of making the test, the more you can get them thinking not only of their own mistakes and awareness of their habits, but sort of the habits of the test. What are they trying to, get from me on this question? The better off they'll be. And so I think that the test in tutoring, there's sort of two aspects. There's content, which is the math that you learn, and there's reasoning. And the SAT is a reasoning test, meaning that they don't care how you get the question right, so long as you get it right. If you bubble the right thing, whether it's a blind guess or you spend 20 minutes doing intense algebra, they don't care. And so because of that, you can use that to your advantage. I like to say right at the outset with students that there is no right way to do a problem. Doing it by algebra or doing it by guesstimation, those are all right. And it's really what you're trying to do is not only calm the student down, but you're trying to give them tools and a sense of the multiple pathways they can take to try and get to the answer. And because of that, almost every problem on the SAT can be done in a different way. And the more you practice and the more they're able to practice, you're able to find out, sometimes this strategy is better for this type of problem, and other times it might be, the shortcut might actually take longer than just doing the algebra. And so while content is important, and particularly with math, the good and bad thing about the test is that unlike science on ACT or something, there's specific topics that you can go over. You can review slope of a line. You can review equations of circles or parabolas. But that can also get overwhelming just because there are far more mathematical concepts than grammatical ones or things of that sort. So it really is best to start with techniques and strategies to get them into game mode with the test. So just briefly, the format for the SAT, as Maggie went over, the first two sections are reading and writing, and then the last two sections are the math. The first section is short and there's no calculator. There's only 20 questions. There are 15 multiple choice, and there's 5 student response or grid-ins. Section 4 is much longer. It's the bulk of the math, 38 questions in 55 minutes. There's 30 multiple choice, and there's 8 grid-ins for a total of 58 questions in 80 minutes. So right off the bat, really for any test, but depending on the strengths of your student, it's a worthwhile question to ask. How will they prepare? How will they get themselves in the right mode? As you notice, section 4 is more math than section 3, and it's always going to be the last part of the test. The kids have been taking, they've been working for 2.5, 3 hours at this point, and they're probably understandably fried, particularly if this is a kid who doesn't feel math confident, he should give himself that extra boost so he doesn't just crash and burn at the end. And so even though a lot of this does seem evident, it is worth having conversations about how they can prepare, how they can use their relaxation time, whether they're going to the bathroom or eating a snack. But really every little bit of energy helps. And multiple choice, pretty straightforward. On the SAT, there's only 4 options. And more often than not, they are ranged from lowest to highest. So it might be A is 2, B is 4, C is 6, D is 8. As we'll discuss later, that format can save you time in how you can apply some of these strategies, because you can rely on that always being the case. Though it's not official, there is a trend that the test goes in order from easiest to most difficult. However, that does reset. So multiple choice 1 through 30, 30 is going to be much harder than number 2 or number 4. But when you get to the grid-in section, which is always after multiple choice, it reverts back. So if number 30 is the last question for multiple choice and 31 is the first grid-in, 31 will always be easier than number 30. This has probably been discussed before, but an obvious strategy that some students don't always think of is to not leave anything unanswered. In the past, as you might remember, the SAT would have penalized you for guessing incorrectly, but that's no longer the case. And that should be used to everyone's advantage. If you have 4 choices and you're randomly guessing on everything, you'll get 25% right, which isn't what we're shooting for, but that's better than leaving it totally blank. With regard to questions ordered by difficulty, and depending on what caliber of student you're working with, if you're working with someone who's getting 650s and wants to break 700s, they're already at one end of the bell curve. And so, getting tons and tons of points is going to be harder for them because they're already at such a high percentile. However, in these cases, you have very high achieving students who are still of the mindset that they aren't worthy and they aren't, good enough. And so they think that everything they're doing is a trick and that the test is trying to trick them. And though sometimes that is the case, sometimes the answers to the math really are as easy and straightforward as they seem. However, you can sort of check yourself. Like it says, if number 8 is super easy, then you can feel okay about it. But if you're figuring out now, if number 28, boom, 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 I got it in 3 seconds, odds are you're probably falling for a mistake that they want you to fall for. And you might make that mistake a couple of times in practice, but once a student starts seeing that, they'll realize that, here are the traps that they're setting for me, and I'm not going to fall in them. Another obvious thing with multiple choice, if you can eliminate at least one option, that already drastically increases your chances of getting it right. Educated guessing is a big part of the game if you really have no idea. For grid-ins, in my experience, I really haven't had students who have had issues with the grid-in, but it's important to note that it's bubbling. So when you're filling in the grid, that does nothing. It's all about how you bubble in the answer, and you can either start a line to the left side of the 4 grids or to the right side. And as it says here, multiple answers typically are acceptable. There are some questions that only have a single answer, but there are many times where you can put several things. So you could write 2/3 for 2/3, or you could put 0.667 or 0.666. But in the case of a repeating decimal, you can't truncate it. You would have to, complete the entire grid. When it comes to fractions, you don't have to reduce. I think that it's wise to always just get things into simplest form, because they're always going to put their answers in simplest form. But if you put 2/3 or if you put 4/6, they'll also be correct. So one potential strategy you can use with grid-ins, this depends on the student, but say you have a student who is continuously pressured for time. It is far easier to randomly guess correctly on a multiple choice question than on a grid-in. So though I don't recommend this for every student, it might be worthwhile in certain cases to suggest that they start with the grid-ins. As a reminder, the first grid-ins are very easy as well, and there's always fewer of them. So it really shouldn't throw them off too much, but it's better at the last second to be guessing on multiple choice rather than trying to just make up numbers. On the topic of calculators, Section 3, you cannot use it. Section 4, you can. As I'm sure many of us have experienced already, there are a lot of students who are very dependent on their calculators, which ideally you want to encourage them to practice and, freshen up on their arithmetic skills so they're not so dependent, but it can be nice to just have them close by. The reality is that obviously no question on Section 3 needs a calculator, though there might be some that you would prefer to have it, but they're never going to ask you on Section 3 to be multiplying, 5-digit numbers by themselves. They're really never asking that for Section 4 as well. But Section 4, you can use the calculator, although it's very rare that they're asking you for multi-step, very rigorous calculations. Just briefly on the topic of what calculators to use, there's an official list, and I think what's most important is that your student is taking the test with the calculator that they're used to. They shouldn't be picking one up, some loner one the day of. They should feel confident. And that said, you really only need, just like a standard calculator, but most students at this point have a TI-84 or something of the like. And those are very helpful because when you have the ability to graph, there are sometimes you can just plug in an equation and look at it graphically. And that's just one more way of solving the problem. Calculators can also be helpful when you do have ugly numbers and you just have to use brute force. And sort of what I mean by that, I apologize for the formatting of the radicals, but let's say you're doing a problem and you've got it down to the square root of 20, and that's your answer. And let's say your student doesn't remember, doesn't know how to simplify. Well, all of the answers that they list, none of them are square root of 20. And if you don't know how to simplify them, it would be a shame to do 99% of the work and mess up at the end. So that's an example of where the calculator can come in handy because you can brute force 2 times square root of 5, 4 times square root of 5, etc. And you'll see that those numbers will match up. And calculators can be particularly helpful when you have radicals in the denominator and with decimals and fractions, because there are a lot of students who are pretty uneasy in converting back and forth. And so they might have done the problem with fractions because 3/4 is easier to manipulate than 0.75, but the answer might be in decimals. So that's something to keep in mind. In terms of content, the SAT has these sort of bizarre, unnecessary section headings, and they are Heart of Algebra, Passport to Advanced Math, Problem Solving and Data Analysis, and Additional Topics. You'll notice that the first 3 provide a subscore, and you'll likely see these on your diagnostic tests as well. And the majority of the test is Heart of Algebra, which is 33%. It's worth noting that problem solving and data, and we'll get into all of these in a moment. Problem solving and data analysis is only on Section 4, and this is like graphs and interpreting things like that. So they aren't necessarily calculator intensive, and they are distributed throughout the whole test. So there are quite a few questions where it is really as simple as, can you read this graph? Passport to Advanced Math is sort of higher level algebra. It's more than just linear. You're getting into quadratics. And the Additional Topics is sort of a grab bag of Algebra 2 and geometry. And it's entirely possible you're working with a student who hasn't necessarily seen these topics. And because of that, there is no subscore. And there's really only 6 questions on the test. So that's sort of the hardest section to grapple with because there are so many individual topics that could make up those 6 questions. But typically, I mean, it depends on your student what you are working on. Something like some of these harder questions, the higher level parabolas or geometry, oftentimes the concept might be a higher grade level, but the question they're asking really just benefits if you've seen it before. So depending on your student, if your algebra is what needs to be the strongest, that really is the foundation for the math. But then depending on, like, if it's a toss-up of should I work on the knuckle-busting algebra or should I introduce some of the easy additional topics, it really depends. But in the case of problem solving in data math, for example, I was teaching some SAT classes to student athletes up in Yonkers and Westchester. And some of the students were terrific at algebra, but they were from other countries and they had language issues. And so reading comprehension in English was their weakness. And something like they were getting every algebra question right, and they were doing horribly on problem solving and data analysis. So it really depends on getting a sense of your student and then just diving in and trying to troubleshoot where their issues are. For most students, though, the task at hand isn't I have to teach this kid 2-3 years of math in the couple of weeks we're working together. Again, it's really about just getting them out of their own way. And the reality is that a lot of mistakes are careless, and it's very easy to sort of let that go while you're practicing and saying, oh, he made this mistake, he won't make it again. You don't want to you never want to put the student's nose in their mistakes. But every single math question is typically about 10 to 20 points, and it really is a shame to not get those points if you're doing 99% of the heavy lifting only to, fall apart at the end. So just diving in a little bit more, and in our next lesson, we will look at each of these sections in even more depth. But heart of algebra is basically linear equations. It's the simplest type of algebra, no exponents. It's about writing, solving, understanding linear equations. It's really just everything to do with lines and how lines interact in systems. Passport to advanced math is like mostly algebra 2. So it's quadratics, exponentials, polynomials, rational functions, graphing, and then functional notation. For problem solving and data analysis, it only appears on section 4 again. And because there are so many questions, it's distributed throughout, and so quite a few of them are very easy questions. Proportions, fractions, ratios, a lot of the time it's looking at the labels of axes on graphs. There are tons of times where the distance in the x direction is different from the distance in the y, and of course they're going to put the answers that assume that you haven't noticed that. So it usually doesn't take a student that many times to make that mistake to figure it out. But again, there are so many easy points to get, and you want to make sure that your student is getting those. If there's a topic they haven't seen, hopefully you can get to all of them. But it's really just about minimizing the mistakes that they can easily avoid. And sort of because of this reading comprehension, again, this is the closest analogy to the ACT science section, where really these types of questions are often less about do you know how to do math and more do you understand how to translate the words into math. Additional topics, again, don't give you a subscore. It's the smallest section with only 6. When it comes to geometry, it's talking about angles, triangles, circles, area, and volume. For trig, it's typically, the trig is, from my experience, easier than what they have on the ACT. And also with imaginary and complex numbers. They really aren't getting horribly in-depth or complicated. But again, yeah, if they've seen the concept, they can normally figure it out. But there are many students who just, as a function of only having taken algebra or maybe being in geometry when they're taking the class, they aren't up to speed with these topics. So now diving into general strategies. Again, some of these are self-evident. Certain students, for a lot of students, this is their primary, first or second time really taking a standardized test. And so some things that might seem obvious, and also sometimes students don't necessarily, facial expressions, they don't necessarily share what they are familiar with and what they aren't. So even things like circling the question and showing your work, I sort of go in with my hands up, acknowledge it. Like there's no formula. It's not rocket science. Most of these things, all of them are common sense. But circling the question is helpful for just reading comprehension in general. I think a typical mistake that is made is that students are circling every little bit of information, when in reality, the most important thing and the most common mistake is they lose track of what the question is actually asking. In terms of showing your work, again, you get, unlike most tests in class, you don't get partial credit, but you also don't get a prize for doing questions in your head. And it's typically boys who are more stubborn to show their work. But that's something to nip in the bud right away, because it's when you're dealing with negative signs and algebra, and these are students who might not be the most confident with their computational skills, it doesn't add. If anything, it saves time than trying to do it in your head. And particularly with geometry problems, if there isn't a picture already there, you almost always, like in every case, you'll need to draw a picture. Maybe you can solve it without, but again, you don't get any prize for doing it in your head. And so this was just an example of the first is sort of what I see a lot of students do when they're circling, which is over-circling, when in reality, what they really should be doing is focusing on what the question's asking. Because at some point, noting every single thing in the question, there's a diminishing returns. The fundamental questions that you're asking with all of these are, what do I want? What is the question asking me for? And what do I know? What has the question already given me? And then you think, how can I take what they've given me to answer the question that they're asking? Again, it is straightforward, but if you are just putting these questions in the mind of your student, they can ask themselves and they can make these connections faster. A lot of this does seem obvious, but you would be surprised that these aren't techniques that all students have already integrated into their way of working. So guesstimating is particularly helpful with when they give you figures. And you can always assume that the figure is drawn to scale unless they are giving you something that explicitly says that it isn't. So here's an example of a question. And it's number 29. In the figure below, C is equal to 5 less than twice of B. What is the value of A plus B? And forgive my crude drawing, but the A and C are supposed to be the external angles of that triangle. And so I picked this question on purpose because it is number 29. It's intended to be a difficult question. And for most people, this would be tough. You would have to define the variables in terms of each other. 180 minus A is that interior angle, 180 minus C is the other. You'd have to do all of this stuff. And this is an example where you can just use the figure to your advantage, because forgive that B is supposed to be very clearly an acute angle. So if you look at A and B, that's what you have to add together. And you look at A and say, well, I don't know exactly what that is, but I can tell from the picture that it's obtuse. I know that it's greater than 90. So let's say that it's 120 or 130. So let's go with 130. And B, I know is acute. So I know that that's less than 90 degrees. So let's say it's 60. Well, if I take 130 plus 60, that's getting me to 190. And though 190 isn't any of the answers that's there, there's one answer that's very, very close to it. And in fact, D is the correct answer. And so you might get pushback from students who particularly need, a step-by-step way of solving problems. They might not like how loosey-goosey that is. But you can always back up these assumptions you're making. I know A is obtuse. I know that it's greater than 90. So even if we call that 91 and we call B 89, there's only one answer that's even close to that. And so this is, even if your student isn't satisfied with just, ballparking the answer, that at least gives them a sense of, okay, 60, 130, 190, I think it's D, and I'll come back later and then do all of the algebra that in this case is really unnecessary. This question is difficult because of the algebra. It's far simpler if you use the graph to your advantage. The makers of the SAT know how high school kids think and how they're going to mess up. And I think that's an important thing to share with the student. When they write the test, they intentionally include wrong answer choices, knowing that kids are going to make those mistakes. And so this is sort of a double-edged sword, because if you frame it that the test is always going to try and trip them up, then you're going to have students doubting themselves, particularly sort of the students at the higher end of the bell curve who are, already pretty highly strung. And there are some simple ways of avoiding that. One of them is reading the full question. Again, this typically happens more with the boys I've worked with than the girls, but the boys are just so eager to start the problem, get an answer, that they do all of the work and they do everything correctly, and they put the wrong answer. Why? Because they didn't read at the end that it said, which is not, or some other different signifier. There are several questions where there is the function for you to solve, but then it's asking for a new application of those answers. So you might have solved for A and you might have solved for B, and the question's asking, what's 2A plus B, which is totally arbitrary. So you might have gotten A and B correct, but if you're not doing that final step, you're going to get it wrong. And again, these are the questions that are, I think, most important to really focus on, because these are questions where the kid knows it and the kid shouldn't be missing it, and there's no excuse. Now, don't, be abrasive about that, but really make it a point to stress that these are easy points. The harder concepts are, you don't know what you don't know going into the test, but these are avoidable mistakes. And every point counts, particularly when you're dealing with students at the upper end of the bell curve, where, it's very difficult to make the leap from, a 690 to a 720 or those types of scores, just because they're already missing so few questions. So here's an example of one. Number 8, a relatively easy question. A certain bookstore gets a shipment of 24 copies of a new book and sells 18 of them. What percentage of the books was not sold? So it seems pretty straightforward. Okay, there's 18 over 24. That simplifies to 3/4. Boom, 75. We're done. Typical mistake, because I totally forgot. I was so eager to just jump into the number crunching that I forgot that it's asking what percentage of the books was not sold. So that might not have tricked you in this instance, but you would be surprised that you will see students doing this over and over, where they're doing it perfectly and they shoot themselves in the foot. And that can be avoided by, most of the time the question is literally capital N-O-T. But if they circle it, that's just going to increase the chances of them not forgetting about it. Another example, 23, so slightly harder. If X is a number selected from set A and Y is a number selected from set B, how many different values for X plus Y are possible? So take a second to think about it, and think about which answer do you think is the trap? In other words, which answer do you think the test makers are putting because they expect kids to put that one and get it wrong? Just take a second. If you said D, that would be correct, because most people, if they weren't familiar with set notation or really what the question's asking is, they would see, 3 times 3, 9. But the operative word in the question is how many different values for X plus Y are possible. So if you went through and you added them at 1 plus 3, 2 plus 5, etc., you would get 9 total combinations. However, there's 2 repeats. And so because of that, the answer is in fact B. Here's another. Number 30, a hard question. Scott drives to Bob's house at a speed of 30 miles per hour and drives back at a speed of 50 miles per hour. If he takes the same route both ways, what was his average speed in miles per hour for the whole trip? So this is a number 30, and I'm looking, and I think, 30, 50, round trip. So 30 plus 50 is 80 divided by 2, 40. Boom, B, that's the right answer. Now, there are some times on the test, like we've discussed, where that's all it takes to get it correct. Okay, so this introduces the concept of, I've seen it called different things, but let's call it fool's gold. And basically, here's the thought process. We know that the test is ordered by difficulty, and we know that difficulty is determined by the SAT and all of their past testing based on, how many students are getting something correct. So that means that the SAT expects more students to get number 1 right versus number 30. And so if you're doing an upper level question that is almost too easy, it sort of, was this question too easy? Was this question an upper number? If that's the case, then that's usually a tip off that you have fallen for the trap. So, and particularly when you're dealing with your upper level students, you do sort of just want to tell them, the SAT is trying to trick students, but you're not the student they're trying to trick. So if you're dealing with a student at the upper level, you sort of want them thinking like, how would most other kids do this problem? Of course, you don't want to spend all of your time on the test philosophizing over things like that. But if they think that, this is a hard question and my solution came really simply, and I think this is how everyone else would do it, then that's an indication that that's probably not correct. And even if you still have no idea how to do that question, you can eliminate that choice. There's a lot of times where students will be like, I know this is too simple. I know it's not right, but I don't know how to do the problem, so I'm going to put it anyway. Again, there's a lot of times where we shoot ourselves in the foot. And so even though that doesn't make sense, that will often be the choice because the answer that they know is wrong had more mathematical rigor than any of the others. Another common mistake, throughout the test, there can be questions where there is a none of the above or cannot be determined. And I don't want to say that's never the correct answer because sometimes it is. However, typically, if it's the hardest question on the test, that feels a little too convenient. That seems like a typical mistake that the test wants the student to make. Oh, this is the hardest question. Oh, I can just put none of the above. Usually not. So although I don't want to say that it's never the answer, I'd be more willing to bet on a number 9 being none of the above versus a number 30. And I think that's worth passing along to the student. Because in that case, you can sort of assume that that's not the correct answer. So if you were able to eliminate can't be determined, and you were able to eliminate sort of the fool's gold, this is the mistake everyone's going to make, you went from 25% chance to a 50% chance. And, that can make all the difference. So now diving into math-specific techniques. These can be applied to various types of problems, from easy to hard, from arithmetic to algebra, geometry, trig. It's really about the formatting of the test's format of how they present the questions that you can use to your advantage. It's like a puzzle. When you're doing a Sudoku puzzle, it's like if you know the rules behind it, you're obviously going to be able to manipulate and play with those numbers. And similarly, if you're aware of the way that the questions are framed and what they're asking for, you can use that. The two techniques I'm about to go in can be used on about 40% of the questions, which means that theoretically, those 40% can be solved with methods other than the content way, other than doing mathy math. And 40% is about 23 questions, which is about a 480 to 510. So it's unrealistic that you have a student who can't do any math but is getting all of those questions correct. But getting upper 400s without any additional math content, really just strategy, is significant. And then if you were to just guess on the rest of the questions, you did all of those correct and then guessed on everything else, we're talking about a 540 to 590, which might not be the ideal target of your student, but there's nothing to laugh at about those scores. So it really is a testament to using the test to your advantage rather than just going in blind and just being hit by math. These techniques, there are strengths and weaknesses. There are some times where a question can be used this way, and it isn't faster than the math at hand, but oftentimes, particularly with the upper level numbers, you can get hard math questions that you have no idea how to do just by using these to your advantage. The goal for both of these is to turn everything into arithmetic, to get rid of the algebra, to get rid of vague unknowns, the intangible ideas, and just to condense it into easy bite-sized chunks of math. So the first one is called PIN, or plug-in numbers. It is pretty straightforward. You pick a number, you go through the problem following the operations as they've listed them, and then you put the numbers into the choice. You want to use PIN typically when you have algebra in the answers. So if the answers are x plus 4, 2x plus 7, things like that. Because if you pick an arbitrary number and you go through it and you find that answer and then you plug in the number you chose into those answers, one of them, and sometimes multiple, will, it will be the correct answer. And so some typical frequently asked questions are, should you test every choice? Yes, you should with PIN, because it is possible that you get two answers, particularly if you're choosing something like 1 or 0. There are times, if you're dividing by a 1, that might not be so helpful. But, so worst case scenario, you pick two numbers, and typically that will narrow it down to only one choice. If you have two choices, you first want to eliminate everything else, so you're only dealing with 50-50. That right off the bat increases your odds. But before you randomly guess, try that different number. The typical numbers you want to hit are 1, 0, a negative number, and a fraction. And if you try those at that point, you will have eliminated it down to the one answer. Types of PIN problems. Where can you best use the strategy to make your life a little easier? You can use it with explicit variables, which is when the answers literally have variables in it. But it can also work when there are multiple variables in the answer. When that's the case, you can use PIN for each variable independently. And sometimes the problem will give you restrictions on the variable. When that's the case, you want to plug in for one variable, then use that value to figure out the other one. So sometimes there's a couple of steps to it, but it's often faster than the proper way of solving. Also, typically with implicit variables, what that means is there might not be variables in the answer, but there is still some parameter in the question, whether it's an area or a distance or things of that sort, where you can say, let's call distance 100 or 600 or something, and go through and do the math. It can also be used with geometry, and a lot of students are scared off by when the geometry often because they haven't seen it or they don't have that much experience with geometry. But a particular hint is whenever a question contains the word in terms of, like, what is z in terms of x, you can almost always use PIN. So here are some examples. Number 15, how many hours are there in D days and H hours? So that's one where you might be inclined, how difficult is this really? Not so much. You can think about it, or you can just arbitrarily choose numbers. Let's say D is 1 and H is 3. So if there's one day, that's 24 hours plus 3 hours, 27. That's a random number. I just chose that. But if I go through all of those options and I plug in D equals 1 and H equals 3, there's only one answer that it's going to be. In this case, letter B, H plus 24D, because 3 plus 24 is 27. I think I said this before, but it bears repeating. When you have a number in the denominator, it's usually, obviously you want to avoid 0, but you also want to avoid 1 as well, because that is more likely to run into some problems where you're getting multiple of the same answer. Number 14, if x plus 5 is 3 less than y, then x minus 2 is how much less than y? Again, this isn't particularly difficult algebra, but if you have a student who's really not about it, you can plug in a random number. So if we say x equals 4, 4 plus 5 is 9. 9 is 3 less than y, so 9 plus 3 is 12. And, going through and doing the answer, then you get 12 minus 2 is 10. For implicit pin, here's an example of a grid-in. It would be one of the earlier grid-ins. Larry cuts a piece of paper into 2 equal pieces. He takes one of those pieces and cuts it into 3 equal pieces. The area of one of the smallest pieces is what fraction of the area of the original piece of paper? So we could do this algebraically. We could set it up and deal with fractions. Or we can just pick a number. This is what it means by implicit. We have no way of really calculating what the area of that paper is, so let's pick a number. I'm going to say 12. And so now I'm going through the problem. Larry cuts a piece of paper into 2 equal pieces. 12 divided by 2, 6. He takes one of those pieces and cuts it into 3 equal pieces. 6 divided by 3 is 2. What's that fraction? 2 over 12, or 1/6. And then I put number 30 back up. You might remember Scott and Bob, where we made the mistake of 30 plus 50. This is another example with distance, where you could say 150, and you could set up your equation d equals r times t. So you could say the distance was 150 divided by 30 miles per hour. That's 5 hours. Then 150 divided by 5, or 50 rather, is 3 hours. So then 5 plus 3, 8 hours, without getting into ugly algebra. So the second technique is called back solving. And basically the idea of this is that you use the answer choices to your advantage, where you pick the answers, or you pick one of the answers, pretend it's the answer, and then go through the problem and see if it fits. If it fails, you want to figure out if you need a bigger or smaller number and repeat. So sometimes this can be tedious because worst case scenarios, you're trying all 4 things before you get to the right answer. But this is another example of how you can use the structure of the test to your advantage. Because when the test is ordered from least to greatest, it makes sense to actually start in the middle, either B or C, because if you typically from the answer, if it's an incorrect answer, that will suggest to you whether you need to go higher or lower. So even though it might still take a little bit of time, you might have to plug in 2 or 3 numbers, it's at least giving you multiple pathways. If I plug in B and it's incorrect, depending on that, I know either to go A or C. If that B is larger than the correct answer, I know that I should go to A. This is the typical rule of thumb, that is starting back solving in the middle, unless the question's asking for smallest or largest. In that case, if it's smallest, start with A. If it's largest, start with D. Frequently asked questions. If the first choice I try works, should I try the other choices to be safe? In this case, unlike PIN, there's no way that more than one choice will work out. So you can have confidence. If you back solve and put one of those answers into the question and it's correct, then it's correct. Boom, you're done. You can move on. What if you're not sure? What if the answer you get is incorrect, but you don't know whether to go up or down? Then at that point, you're just making an educated guess of which way to go. Is there still a scenario that you spent 10, 15 extra seconds doing an additional computation that you didn't have to? Perhaps, but you're still cutting out some time. And for some students, that makes all the difference. So some examples of back solving. Number 8, pretty easy, low numbered question. If 5 minus 3 times x minus 1 equals 8, what's the value of x? Okay, so this is an example where it's quite straightforward algebra. Really not so difficult to do the proper way. And there are some times where these techniques might take longer than doing it the proper way, but just as an example, let's start with B. If you plug in B, or for 0, you plug 0 minus 1 is -1. -3 times -1 is 3. 5 plus 3 is 8. That's correct. Boom, you're done. Slightly harder problem. 17. A young clothing designer sells t-shirts for $24.50 and sweatshirts for $61. The designer's revenue, misspelled, from selling a total of 17 pieces one Sunday at the local flea market was $599. How many t-shirts were sold that day? So the proper way of doing something like this would be with a system of equations, which is a concept that a lot of students don't remember, are uncomfortable with. But you can use back solving in the exact same way, where let's say you plug in 5 again. You pretend What are you looking for? You're looking for t-shirts. So you're defining 5 t-shirts. You go through the problem, you do the math and plug it in. In this case, 5 is too small. So I know, oh, let's try, 1 up. I know I can eliminate 4 because that will only yield something smaller. So you try 12, you plug it in for 12 times 24, 50 plus 5 times 61. And sure enough, that is the answer. Another example, a more straightforward system of equation. 2x plus y equals 12, x minus 3y equals -1. Which of the following ordered xy pairs satisfies the system of equations above? Another example, you don't have to do elimination, substitution, any of the methods. All you have to do is you have to plug in those x and y points. So if we start with B, for 5 is x, 2 and y. When you plug it in, 5 times 2 is 10 plus 2 is 12. That works. What about 5 minus, or 3 times 2 is 6. 5 minus 6 is -1. There's the answer. You didn't have to know how to do a system of equation to get the answer. So just to review these 2 main concepts that you can apply across the math section. You have PIN, and the idea of that is to turn algebra into arithmetic, to take away the abstraction, to make the abstract concrete. We will go into more depth on the applications of these as they pertain to each of the sections, but typical things you want to do with PIN. When you're dealing with percentages, percent, it literally means 100. So with any of those questions, it's always going to be easier to do the math with 100. It's far easier to find 70% of 100 than 70% of 15. So it's not only knowing the concept, but knowing the ways in which the concept can help your student. Because you're doing, it's not just about educated guessing, but it's educated applications of these strategies. When you're dealing with linear models and lines and things like that, typical thing to remember is the intercept. So plugging in x equals 0 will often be helpful. When you see which of the following must be type questions where that phrase is contained, that's usually a hint that you will have to plug in more than one number. And we talked about that earlier, the -, 0, 1, and fractions. Then with back solving, the idea is that you're taking the answers they give you and putting them through the functions of the question. And you know that it's a back solving question typically when the answer choices are numbers, when the question is difficult and you don't see an immediate path of how to solve it, and the question is asking specifically for the value of something. You can't back solve when there's variables in the answers. So PIN and back solving very rarely actually overlap. And you can't back solve when it's not asking for a value. And so that was a brief introduction into the test, the structure of the test, sort of general strategies you can start talking with your student about, just test taking in general. And then we talked about 2 concepts, PIN and back solving, which you can apply on both sections of the math across a range of difficulty and across a range of types of questions. And with these strategies, you can answer a significant chunk of the test without even discussing content. And the homework for this week will be just applying PIN and back solving. Yes, a lot of these questions all of these questions can be solved other ways. Sometimes it will be easier to solve it other ways, but it is good practice for you and then for your student to get a sense, to be able to identify immediately with a question, how many ways can I go about this? Because it can make all the difference in the game time scenario of, okay, I know I can do a system, I know I can back solve, I know I can, solve the system 3 different ways. Okay, I'm going to go with this route. It's really about navigating and making, the best, most efficient decisions. And next week we will dive into the content while continuing to put these techniques into practice. So thank you all for your patience and your participation, and I'm looking forward to seeing you next week.